Welcome to Unacademy, the largest online e-learning platform, and welcome to Unacademy semester exams. The course that we are dealing is network analysis and transmission lines. It's a crash course, and the topic is network functions. And here today we will learn about concept of poles and zeros. Concept of poles and zeros. Before that, let me tell you about myself. I'm Vaishravan Kumar, having 7+ years of teaching experience and mentored more than 5K students for GATE and engineering services and also cracked GATE. Let me also tell you about the Unacademy Learning App installation procedure. Type Unacademy Learning App in Google Play Store, and then you can click on this install. Once you do that, you can opt for GATE and engineering services and click on this plus icon and click on get subscription. You have plus and iconic subscriptions. You'll get a dedicated mentor for your preparation in iconic subscription, which is a very good opportunity for the students. And you can use my code YSK10 to get the maximum discount of 10% and click on this proceed to pay. Once you click on proceed to pay, you have debit card, credit card, EMI, UPI, wallets, net banking. You have so many options for getting subscription to Unacademy, the largest online e-learning platform. So let me tell you about Evolve for Gate 2022 and Ascend for Gate 2023. So starting new batches for Evolve for Gate 2022 and Ascend for Gate 2023. So get subscription. We have the top educators to train you. So that was about the Evolve Gate 2022 and Ascend Gate 2023. Right now, let me also tell you about Unacademy Combat. We have another Combat, India's largest fortnightly competition for GATE on January 12th, 2020, 6 p.m. for ME, CE, and WE students. So this is a good combat, the challenging and original questions curated by the best educators of Unacademy, and it is a super fast and fun with all India live leaderboard, and see how you rank against the others from all over India with a live leaderboard that shows real time ranking after each and every question. So take it live to compete with the best, know where you stand among all other contestants, and identify and improve your weak areas with detailed video solutions by the top educators. Get in depth video solutions for the questions right after the contest. So this is how it looks. You have a score, a leaderboard, a rating, awards. So compete, crack, and conquer. So, Unacademy Combat, Compete, Crack and Conquer, India's largest fortnightly competition. Assess your gate preparation in 65 minutes, challenging or and original gate questions curated by the best educators. And the eligible branches are ME, CE, and EE. And take it live to compete with the best, super fast and fun with all India live leaderboard, and identify and improve your weak areas through a detailed video solutions. The next combat goes live on January 12th, 2021, 6 p.m. So you can register for free and unlock. You can use Crackgate or you can also use my code YSK10. So it's the competition format is something like this. It is a 60 minutes combat with 15 questions and 4 combats, 3 cohorts. So relative scoring will be based on the speed and the accuracy, right? So enroll now in Unacademy Combat. To participate in Unacademy Combat, sign in Unacademy Learning app through Google Play Store. To unlock, you can use Crackgate. So the topic for today is that was about the Unacademy Combat. So I hope you'll make use of it most. So the topic for today is concept of poles and zeros in network functions. So let us see what is it about exactly. We have seen network functions. So let us quickly review that first so that you'll understand network functions. We have driving point functions and impedance functions. Sorry, driving point function and transfer functions. So driving point function and transfer functions we have in this. So what was driving point function? It was, again we had a driving point impedance function and driving point admittance function. Driving point impedance function and driving point admittance function, right? So in transfer function we had voltage gain or voltage transfer function or current transfer function. Transfer impedance function and transfer admittance function. So these were what we had. Let's also look at one by one. Let us say we have driving point impedance function. What was it? It is directly I'm writing impedance function. Z1 is equal to V1 of S by I1 of S. That is the ratio of transform of voltage to transform of current at the same port. Similarly, Z2 is equal to V2 of S by I2 of S. Similarly, if you write, we'll come to a conclusion from this. I'll just tell you one more important thing from this. That's the reason I'm just trying to revise what we have learned in the previous sessions. So driving point admittance function. What is driving point admittance function? Y1 of S is equal to I1 of S by V1 of S, and Y2 of S is equal to I2 of S by V2 of S. Similarly, let's also write the transfer functions. First, I'll write voltage transfer function. Let's also write the voltage transfer function. Voltage transfer function. You can denote this by alpha or any letter that you feel comfortable. It is V1 of S by V2 of S transfer function, that is alpha 1 2. Now alpha 2 1 of S can be written as V2 of S by V1 of S. It is the ratio of transform of voltages at two different ports. Transform of voltages at two different ports. Similarly, V1 of S. Similarly, you can write current transfer function. You can write current transfer function as I1 of S by I2 of S or I2 of S by I1 of S. This is the current transfer function. Let's also write transfer impedance function. What is transfer impedance function? Z12 of S is equal to V1 of S by I2 of S. Z21 of S is equal to V2 of S by I1 of S. It is a ratio of voltage transform at one port to the current transform at the other port, right? Now you can also write transfer admittance function. Yoga transfer admittance function, you can write y12 of S is equal to and y21 of S is equal to as I1 of S by V2 of S and I2 of S by V1 of S. It is a ratio of current at one port to the current transform at one port to the voltage transform at the another port. So let's write all these things at one place and try to understand something from this. So let's write all these. Z1 of S is equal to, let's not even take this. I'll just directly write what was that. It was V1 of S by I1 of S and V2 of S by I2 of S, driving point functions. Then V1 of S by transfer function, voltage transfer function, and I1 of S by I2 of S, or you can also write V2 of S by V1 of S and I2 of S by I1 of S. Similarly, in driving point functions also you can write admittance function I1 of S by V1 of S, I2 of S by V2 of S. Similarly, you can also write V1 of S by I2 of S or I1 of S by V2 of S and V2 of S by I1 of S or I2 of S by V1 of S. These are the all transfer functions that we have studied till now. Network functions. These are all the network functions. Now what do you observe from this is a ratio of voltage to current or current to voltage or voltage to voltage and current to current. That means you can say this network function, any function, I'll call this as f of s, has a numerator polynomial and a denominator polynomial. A numerator polynomial and a denominator polynomial. And this polynomial is said to be a proper fraction. It is said to be a proper fraction if it is said to be a proper fraction if the numerator polynomial is always less than the denominator polynomial. The numerator polynomial is always less than the denominator polynomial. So what have we concluded? Every function, a network function f of s is equal to numerator by a denominator. It has a numerator polynomial as well as a denominator polynomial. Now from this you will have to learn what is called as poles and zeros of the function. Now we will try to understand what are these poles and zeros. Now if you consider, let us consider one example. Let us say f of s is equal to k into s plus 2 by s into s plus 4 into s plus 6. Now let this be a function f of s. Let us assume that we have obtained this function k into s plus 2 by s into s plus 4 into s plus 6. Now what are poles and zeros is when you take this numerator polynomial and find the roots, that is s is equal to minus 2, and consider the denominator polynomial and find its roots, it is called as s is equal to 0, minus 4 and minus 6. Now these values of numerator when you are making it to 0 and values that you get are s is equal to minus 2, and denominator when you make it 0, you get s is equal to 0, s is equal to minus 4, and s is equal to minus 6. The roots of the numerator are called as zeros, which make the function value 0, and the roots of the denominator are called as the poles of the given function, or called as the poles of the given function. Okay, right? So what are zeros? I can just simply write zeros as the roots of numerator polynomial of a network function, or a transfer function, you can say network function. And what are poles? Poles are the roots of denominator of a network function, right? That is a transfer function. Okay, so the poles and zeros are these. Now these poles and zeros, let us consider the same example. F of s is equal to k into s plus 2 by s into s plus 4 into s plus 6. Now can I say what are zeros from this? What are zeros? How do you find zeros? Numerator is equal to 0, that is s plus 2 is equal to 0, implies s is equal to minus 2. Now at a 0, let us find the function value. At a 0, that is f of s value, if you try to find at a 0, what is the value of this 0? This 0 is s is equal to minus 2. Let us substitute that k into s plus 2 by s into s plus 4 into s plus 6, that is k into minus 2 plus 2 by s into s plus 4 into s plus 6. So this is making the value of the function 0, that is at zeros the function value, at a 0 function value f of s is equal to 0. Now similarly let us consider poles. Now what are poles? The denominator polynomial equated to 0, or the roots of the denominator. S into s plus 4 into s plus 6 is equal to 0. Now what are the values of s? So s is equal to 0, minus 4, minus 6. Let's try to substitute these values now. So what is f of s is equal to k into s plus 2 by s into s plus 4 into s plus 6. Now at poles, what are the poles? Let us take s is equal to minus 2 is one pole, s is equal to s is equal to 0 is one pole, s is equal to minus 4, s is equal to minus 6. Now if you substitute this in function value, f of s is equal to k into s plus 2 by 0 into s plus 4 into s plus 6 will give me an infinite value. Similarly, f of s is equal to k into s plus 2 by s into minus 4 plus 4 into s plus 6 will give me an infinite value. Similarly, f of s is equal to k into s plus 2 by s into s plus 4 into minus 6 plus, sorry. You also need to substitute the value of s here, 0. When you are substituting, you need to substitute at all places of s. Even if you substitute that also, the value will not change. So let's try to substitute each and every place. So this is 0, 0 and 0. What would this give you? Let us see. Let us cross check this once again. So this will give you k into 2 by 0 into 4 into 6. This is infinite, right? Now similarly, if you observe this also, what is that value that is you are going to get? Minus 4 plus 2 and minus 4 plus 6 will give me k into minus 2 by 0 into, yes, what is s value here? Minus 4. Minus 4 into plus 2. So this will also give me infinite. Now if you observe this, s is equal to minus 6. So this is k into minus 4 by minus 6 into minus 2 into 0. This will also give me infinite value. So we can write at a pole function value f of s is equal to infinite. So we can conclude that at a 0, function f of s value will be 0. At a pole, f of s function value will be infinite. Clear? From this, you know already s is actually sigma plus j omega. This is Nepper frequency, this is radian frequency. So you can plot this in an S-plane. So what is an S-plane is, if you consider imaginary axis as j omega and real axis as sigma, that is an S-plane. Now this is sigma, this is j omega, and this plane is called as S-plane. So you need to mark these values as 1, 2, 3, 4, 5 and so on. Here you'll get -1, -2, -3, -4, -5 and so on. On imaginary axis, what should you get? J omega. That is, you should write it as J1, J2, J3. And on negative imaginary axis, this is minus J omega. This is minus sigma. So you can write it as minus J1, minus J2. Karthik Jilla, good evening. Welcome. Soumya, welcome. Varnasri, good evening. Srinivas, welcome to Unacademy. Srilata, welcome to Unacademy. So minus J2, so minus J3, minus J4. So this is S is equal to sigma plus J omega, and this is called as a S plane. Real axis is sigma, imaginary axis is J omega. Right? Now what we do here is we will substitute the values of, we will plot these values of sigma and j omega, roots of this function. So zeros are represented by a circle and poles are represented by a cross. And when you sketch this, when you mark these values on an S plane, that is called as a pole zero plot. That is called as a pole zero plot. I'll also tell you about the stability of a function. I'll also tell you about the stability of a function. First, let us learn what is pole zero plot. See, that means you need to sketch poles and zeros in S plane. That will give us what? That will give us a pole zero plot. That is called as a pole zero plot. Now let us take the same example that we have considered. F of s is equal to k into s plus 2. This is gain. S into s plus 4 into s plus 6. Now how do you plot this? So we need to consider an S plane like this. Let us consider an S plane. This is an S plane with real axis as sigma and imaginary axis as j omega. So this will be sigma and this is j omega minus j omega and this is minus sigma. Now let us consider this as 1, 2, this value is -1, -2, -3, -4, -5 and -6. Okay. Vishal, good evening. Welcome to Unacademy. This is J1, J2, J3 and here you'll get minus J1, minus J2, minus J3, minus J4. Right? So now what we'll do is we will try to find first zeros of this given function f of s. What is zeros? S plus 2 numerator is equal to 0. So S is equal to minus 2. How are zeros represented by? Zeros are represented by a circle. And how many zeros you have? Only one zero. Where is it? It is at minus 2. So here I'll mark a 0 at minus 2. This is minus 2, right? This point is minus 2. So it is, we'll mark it as a circle. We'll mark it as a circle. Now let us also try to find poles. Let us also try to find poles. Now what are the poles of this transfer function? S into S plus 4 into S plus 6 denominator. So S is equal to 0, S is equal to minus 4, S is equal to minus 6. So how do you represent this? You will represent this by the poles by a cross mark. You will represent this by a cross mark. So let us try to do that. Where is the first pole? How many poles are there? There are three poles. And where is the first pole? It is at origin. So let us represent that here. It is at origin with a cross mark. It is at origin with cross mark. What is the second one? It is S is equal to minus 4. So at minus 4 also you need to represent it with a cross mark. Now, where is the third pole? It is at minus 6. So, mark it as cross at minus 6. So, this plot is called as a pole 0 plot. And you can extend this pole 0 plot and draw its root locus and find the stability in control system engineering. Generally, you will do this in control system engineering. Okay, let us try to consider one more example now. Now, f of s is equal to, let us say you have k into s plus 2 or s plus 1 by s into s plus 3 into s plus 5. Now, if this is the question is find, just tell you that question is some question. Obtain the pole 0 plot of the given function. Obtain pole 0 plot of the given function. Obtain pole 0 plot of given function. This is the question. So for that, first what you need to do, you need to find what are zeros, pole zeros, right? Zeros is numerator equated to 0. So s plus 1 is equal to 0. So s is equal to minus 1. I'm just neglecting this k, or k is taken as 1. Now, so how many zeros are there? Only one zero. And where is it? At s is equal to minus 1. Now let us write about poles. So poles is denominator equal to 0. So s into s plus 3 into s plus 5 is equal to 0. So you can write s is equal to 0, or s plus 3 is equal to 0, or s plus 5 is equal to 0. From this you can write s is equal to 0, s is equal to minus 3, and s is equal to minus 5. So you have three poles. How many poles are there? Three poles are there. Where are they? At s is equal to 0, s is equal to minus 3, and s is equal to minus 5. So let's try to plot them now. So consider an S plane. So let us consider this as an S plane. This is real axis and this is negative real axis, imaginary axis, and minus j omega. So this is origin. This is 1 and 2, minus 1, minus 2, minus 3, minus 4, minus 5, and minus 6. Now where are the zeros? What is this plot named as? It is a pole 0 plot. Now where are the poles and zeros? Let us look at poles and zeros. there is a 0. 0 is represented by a circle and pole is represented by a cross. So it is s is equal to -1. At s is equal to -1, you have a 0. They'll represent that. This is a 0. And at s is equal to 0, you have a pole. So at s is equal to 0, you have a pole. And at s is equal to -3, you have another pole. At s is equal to -3, you have another pole. And at s is equal to -5, you have another pole. So this is the pole 0 plot. This is simply pole 0 plot. Okay. So now let us try to take one more example. Let us consider one more example. F of s is equal to k into s by, or I'll just take, I don't want to take s here. I'll only take 1 by s plus 1 into s square plus 2s plus 3. Let us see how do you get this. So we need to find first roots or poles and zeros. Let us consider some k here, 1 into k gain. So let us consider this function, and the same question is obtain pole 0 plot. So what we shall do is, we shall consider this. Before that, let us first find the zeros and poles. Let us first find the zeros. What are zeros? You don't have any zero. There are no zeros because there is no s term in the numerator. Now let us consider, unlike the previous cases, let us consider poles. So denominator s plus 1 into s square plus 2s plus 3 is equal to 0. So either s plus 1 is equal to 0 or s square plus 2s plus 3 is equal to 0. Now let us try to find the roots. So s is equal to -1. You cannot do this. You can find the roots. You can find it as minus b plus or minus root b square minus 4ac by 2a. So you can write this as ax square plus bx plus c. So just try to find its roots. You'll get, what do you get? Minus 2 plus or minus under root of 2 square minus 4 into a is 1, c is 3 by 2 into 1. So it is minus 2 plus or minus under root of 4 minus 12 by 2. So what do you get here? Minus 2 plus or minus root minus 8 by 2. So you can also write it as minus 2 plus or minus 2 root minus 2 by 2, or it is minus 2 plus or minus, sorry, you can just cancel 2 in the numerator and denominator. It is 1 plus or minus root minus 2. Is this correct? Minus 1 plus or minus root minus 2. When you cancel 2. So minus 1 plus or minus root 2j. Minus 1 plus or minus root 2j. So that is under root 2 will give you 1.414. That is minus 1 plus or minus j 1.41. So this is s2 and s3. You got three values now in the denominator. If you see, just look at this. You have s is equal to, how many poles are there? This is one pole, and you also have two more poles. So let us consider them. So poles are, what are the poles now? S is equal to minus 1, s is equal to minus 1 plus j 1.41, s is equal to minus 1 minus j 1.41. Now you need to plot them. So instead of this, let us consider s1, s2, s3, three poles. So just take this and try to plot. Do you have any zeros? No, you don't have any zeros, so need not worry about them. So just look at these poles and take the S-plane. Consider this as the S-plane. Now consider these values. This is sigma and this is j omega, negative real axis, negative imaginary axis. This is 1, 2, minus 1, minus 2, minus 3. This is j1, j2. Here also minus j1 and minus j2. Now let us try to do this. So where are the poles now? Let us check where are the poles. At minus 1 you have a pole. So at minus 1 you have a pole. And there is another pole at minus 1 plus j1.4. This is what is important. This is minus 1 plus j1.4. Somewhere around here you'll have 1.4 plus j. So this is another pole. You have minus 1 minus j 1.4 somewhere around here. So this is the pole 0 plot. Now in this case we got roots in the quadrants, and in the previous cases we got roots on real axis. Augustus, good evening. Vamshi, good evening. Welcome to Unacademy. So this is the pole 0 plot. Let us consider one more example and then we'll learn about stability. The question is, obtain the pole 0 plot of function f of s is equal to k into s plus 3 by s minus 2 into s plus 4. Now let us try to find poles and zeros. This is very easy. Let us try to find first zeros. What are the zeros here? Numerator s plus 3 is equal to 0. So s is equal to minus 3. This implies s is equal to minus 3. So a 0 is present at s is equal to minus 3. Now let us consider poles. Where are the poles? Now s minus 2 into s plus 4 is equal to 0. So s is equal to 2 and s is equal to minus 4. So here this is a 0 and these are poles. Alright. So let us try to plot this now. I'll just consider a S-plane here. Let us say this is the S-plane, from which we can say this is real axis, this is imaginary axis. 1, 2, 3, 4, minus 1, minus 2, minus 3, j1, j2, minus j1, minus j2. Now let's look at 0 is present at minus 3. Therefore here you will have a 0. I can represent it by a circle. And you have a pole. Where is the pole? Pole is located at 2. So this is in right half of S-plane. So we'll call this part as right half of S-plane and this part as the left half of S-plane. I'll also tell you. Now you also have a pole at minus 4. So there is another pole at this point minus 4. So this is the pole 0 plot. This is the pole 0 plot. Now let me tell you this is the S-plane, where we call this as real axis and this as imaginary axis, negative real axis, negative imaginary axis. And this part, this is called as this complete is called as the right half of S-plane. This is right half of S plane. This is S plane, right? Wherein S is equal to sigma plus j omega. And this part is called as the left half of S plane. This is left half of S plane. There is an importance to this. That's how we are learning. Now let us check what is about this stability. Let's check about the stability of the system. I'll just tell you with an example. Let us consider 1 by s plus 2 is one function and 1 by s minus 2 is another function. Now if you try, this is f1 of s and let us call this as f2 of s. Now what is the Laplace, inverse Laplace transform? Inverse Laplace transform to this, you will get f of t is equal to e power minus 2t. Similarly, inverse Laplace transform to this, e power 2t. F of t is equal to f2 of t and f1 of t. Now let's try to draw f of t versus t graphs to both. With considering initial conditions as 0 as of now. So let us consider this. E power minus 2t is a decreasing function with respect to time, and this is f1 of t. And this is at t is equal to 0. It is an increasing function with respect to time, f of t versus f2 of t versus t. And you can say that is s plus 2 and s minus 2. S plus 2 and s minus 2, where do these lie? Now let us first look at that also. I'll draw S plane, two S planes I'll consider. So let us call this S plane. First we'll plot f1 of s and then we'll plot f2 of s pole 0 plot. This is sigma j omega sigma. This is minus real axis minus j omega minus j omega. Now let's try to plot it. So first I'll plot f1 of s. So f1 of s, you don't have any numerator, no 0. What is, where is the pole? Pole is at s is equal to minus 2. S is equal to minus 2. So let's call this as minus 1 and minus 2. Here you have a pole. And if you consider 1 by f2 of s function, pole is at s is equal to 2. Pole is at s is equal to 2. So you can say here pole is in left half of S plane, and here pole is in right half of S plane. Can I say that? Now if you observe this, this is a stable system and this is an unstable system, right? So we can say f1 is stable, f2 is stable. From this, f1 of t versus t and f2 of t versus t. So you can say that if the pole is on left half of S plane, then the system is stable, and if the pole is on right half of S plane, then the system is unstable. So we are saying the stability of a system. Actually, a system is said to be stable if for every bounded input, the output is also bounded. Output is also bounded. So this stability can be, it can be a stable system or an unstable system or a marginally stable system. Marginally stable system. So from pole and 0, what we conclude is if poles of a transfer function are on left half of S plane, then system is stable. Okay, now if poles are on right half of S plane, right half of S plane, system is, given function or system is unstable. And it can also be marginally stable, that is it is stable for certain conditions or for certain parametric values. uh, One example is if the roots are on the j omega axis, the system is oscillatory and it can be marginally stable system. So this is about stability. So let us consider few functions which are given, and let's try to obtain the pole zero plot of that. There is a function given, network function. The function is obtain pole zero plot of h of s is equal to, it is given as s plus 1 into 2s plus 6 into, I'm considering this, I'm taking this example from one of the textbooks, Shalivahana. Now if you observe this, you need to, what is that question, you need to get the pole zero, you need to sketch the pole zero plot, you need to sketch the pole zero plot, right? So try to sketch this pole zero plot. For that you need zeros. Zeros is numerator, s plus 1 into 2s plus 6 into s plus 4 is equal to 0. So s plus 1 is equal to 0, 2s plus 6 is equal to 0, s plus 4 equal to 0. So can I write s is equal to minus 1, s is equal to minus 6 by 2 minus 3, s is equal to minus 4. So where are the zeros? How many zeros are there? 3 zeros are there. Where are they? At minus 1, minus 3, minus 4. So you need to represent this by a circle. Now let us consider poles. Where are the poles? So the poles are at denominator, s into s plus 2 into s plus 5 is equal to 0. So s is equal to 0, s is plus 2 is equal to 0, s plus 5 is equal to 0. So where do we have this? So this can be written as s is equal to 0, s is equal to minus 2, s is equal to minus 5. So how many poles are there? We do have same three poles as many number of as zeros, and they are at 0, minus 2, minus 5. So now let's try to plot this. So let us consider this as the imaginary axis, this as the real axis. So this is real axis, this is imaginary axis. So this is real and imaginary. This is the origin. This is 1 and 2, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. This is negative real axis. Okay. Now where are the poles? Now let us consider first zeros. Minus 1, minus 3, minus 4. Minus 1, minus 3, minus 4. At these points you have zeros, so I have marked it with a 0 circle. And now where are the poles? At 0, minus 2, minus 5. At 0, minus 2 and minus 5. So this is the pole 0 plot. Now what can you say? All poles are on left half of S plane, but there is a pole at the origin, right? So you can say that the poles are on the left half of S plane. Next, let us consider one more question and let's try to solve it. So there is a circuit given, and from that circuit we need to obtain the pole zero plot. So it is given, obtain the, till now we were given a function and we were asked to plot the pole zero, sketch pole zero plot. Now we are asked to sketch pole zero plot from a circuit. Previously we were asked to plot pole zero plot from a function. So for this you need to first find the function. So obtain the pole zero plot. Obtain the pole zero plot for network shown. So and the network is this. There is a capacitor given. There is a resistor. And the values are also given. This is 5 ohm, 1 Henry, 1 Farad, 1 ohm, P of t. So let's try to write the solution first. So first we need to find the function. What is that? First we need to find V of s by I of s, impedance function, Z of s, right? So what is that? You'll get, so in order to do that you need to draw the transformed network first. Draw the transformed network, that will be easy. So let's try to draw this. Here you have a resistor, inductor, capacitor. We have learned about this transformed elements in the previous sessions. So this is 5, 1 into s, L should be replaced by ls, and this is 1 farad, that is 1 by s, 1 into 1 by cs, this is 1. Okay. So resistor, if it is R, its transformation is same as R. If you have an inductor, its transformed variable is L into S. If you have a capacitor, its transformed variable is 1 by Cs. So this will be V of S. This is 5. This is 1 into S, 1 by S. Now let us try to find from this. Let's try to consider this in the next slide. So this is the network, transformed network for us now. So to this network, what we'll apply is, we'll apply V of S is equal to, let us consider this is I of S. So how are these two elements? They are in parallel. So 1 by S into 1 by S plus 1. So this is 1 by S plus 1 by S. Cancel this 1 by S plus 1. So this is the equivalent of this part. So this is in series with 5 plus S. So you can write total ZT is equal to 5 plus S plus 1 by S plus 1. So V of S is equal to I of S into 5 plus S plus 1 by S plus 1. So just try to simplify this. What do you get? I of S into 5 into S plus 1 plus S into S plus 1 plus 1 by S plus 1. So you can write, yeah, V of S is equal to I of S into 5S plus 1 plus S square plus S plus 1, 5S plus 5, right? 5 if you are multiplying, S plus 1. So you can write it as V of S by I of S is equal to, that is Z of S is equal to S square plus 6S plus 6 by S plus 1. S square plus 6S plus 6 by S plus 1. So what is Z of S? The function. What is the Z of S? V of S by I of S. Driving point impedance function. So that is, what do you get here? S square plus 6S plus 6. S square plus 6S plus 6 by S plus 1. So to this you need to find zeros. What are zeros in this case? S square plus 6s plus 6 is equal to 0. And what are poles? You can directly write s plus 1 is equal to 0. What do you get here? S is equal to minus 1. At s is equal to minus 1, you have a pole. And if you just try to solve this, this is minus b plus or minus root b square minus 4ac by 2 into a. Let us consider this as ax square plus bx plus c, where these are s1, s2. So minus 6 plus or minus 6 square minus 4 into 1 into 6 by 2 into 1. Now if you just try to solve this, you'll get s1 s2 is equal to 1.26 and 4.7. 1.26 minus and minus 4.73. Now where are the poles? Pole is at s is equal to minus 1. And where are zeros? Just see, there are two zeros. One is at minus 1.6 minus 4.73, minus 1.26, and other one is at minus 4.73. Now let's try to sketch this. So let us assume this as imaginary axis, this as real axis. So if you can just plot, this is minus 1, minus 2, minus 2, minus 3, minus 4. And this is, if you see pole, this is cross. So represent that here. So this is the pole. And where is the 0? 0 is at 1.26. Let us consider this. So it is a 0. And this is minus 4.7. Somewhere here, this is a 0. So this represents the pole 0 plot. This represents the pole 0 plot of the given network. So this is, good evening. So this is about today. We have seen pole 0 plot, that is concept of stability. So thank you all. Thank you once again. As I always tell you, we have India's #1 study channels: Creatrix Gate, Unacademy Gate, Unacademy Gate CE, Unacademy Gate Telugu, Unacademy SSC JE, Unacademy Computer Science, Unacademy Gate Questions, Unacademy Electrical Junction, Unacademy Gate Foundation Engineering, Unacademy Pathshala, and Unacademy Semester Exams. Please do like this video, share this video. You can use my code YSK10 and get 10% off on your Unacademy subscription. Please subscribe to Unacademy and click on this bell icon to get more notification of my classes. Thank you all. Thank you once again for joining me this session on concept of poles and zeros of network functions in course of network analysis and transmission lines.